our artist concepts are going to be the public face for some of these objects. And there's a lot of responsibility that comes with that.
I'm Robert Hurt. I'm the visualization scientist at IPAC, the Science and Data Center for Astrophysics and Planetary Science at Caltech.
My name is Tim Pyle. I'm a multimedia producer at IPAC. I work with Robert.
We've done illustrations of regions where stars form, and cores, the stellar remnants after a star like our sun dies, leaving a white dwarf, a neutron star that's left at the core of a supernova explosion, supermassive black holes that sit in the cores of galaxies.
So rocky planets, gas giants, brown dwarfs, cool stars.
TRAPPIST-1, I was immediately thinking this is going to be the most significant thing that has come out of the Spitzer mission. It's going to be the result that I think Spitzer will really be remembered for. The properties that we come away with from this kind of observation include the diameter of the planet, its orbital period,
whether it's likely to be tidally locked, which will say something about what the planet probably looks like.
If it's less dense than the Earth, it might have more volatiles like water on it, which is why 2 of the TRAPPIST planets were shown as water worlds. If it has a higher density than Earth, then it's probably a little more rocky.
By doing these artist concepts, we are actually getting across the point that no, these aren't just, we know there's a planet there and that's the extent of our information about it. All of these decisions are made in conjunction with the scientists.
I got my PhD in astrophysics from UCLA.
I'm an artist with a Hollywood background.
A lot of times I'm very focused on the science bullet points that I'm trying to get across. We kind of cover each other's blind spots a bit. If you go back and you look at the whole history of space art and science-based illustration for reaching back many, many decades, you have a visual history, a visual record of our evolving understanding. The art is as much a historical record of our changing understanding of the universe as the textbooks that we write.
In the meantime, there are images that inspire, educate, and sometimes just make us say, wow. Yeah. Over the years, NASA has given us spectacular photos and renderings that reveal a colorful and mysterious universe.
No doubt. And now Chris Martinez is introducing us to 2 of the artists behind some of the most iconic space art in the galaxy.
In a small, bright office, working side by side, Robert Hurt and Tim Pyle bring the universe to life.
What we're doing does have real science underlying it.
Robert is an astrophysicist turned artist. Tim, once a Hollywood animator, is now a planet illustrator. Together, they produce some of NASA's most popular images, from renderings of how planets light years away could look, to actual photos of stars and galaxies captured by NASA's powerful telescopes.
And this is sort of how it comes to me.
Many of those images have a dark, grainy start, but color and light reveal an astonishing glimpse of how the deepest regions of space might appear to the human eye.
What I'm trying to do is show people sort of the broader colors that the universe has to offer.
It's a delicate blend of imagination and data. The artists meet with NASA scientists over many drafts to ensure a planet or galaxy's look lines up with the research to make each one as accurate as possible.
I love the challenge. It's kind of like a puzzle to me, of trying to create something that's really cool within the restrictions that we're given by the scientists.
It can take days, even weeks, to produce just a single image. The dazzling final results, enough to keep us all dreaming of the final frontier for years to come. Chris Martinez, CBS News, Pasadena, California.
The artists also say they have to be especially careful when it comes to illustrations of other planets to avoid colors many of us would associate with Earth, like blue for water.
The force is strong with this.
What's your favourite astronomical feature?
There's got to be, I think it's those star-forming pillars that Hubble Space Telescope took this truly amazing picture. Which is a little strange because actually the main thing I research on is galaxies, but actually in terms of beautiful pictures, that really is stunning. And it's just because it's such a beautiful object. It's nothing to do with the fact that it's an astronomical object. If I'd seen that picture hung up in an art gallery, I'd say that's a really pretty picture. There's a bright star just out of the picture, which is kind of blazing down on it and eroding these pillars away, and so you see these pillars of gas and then little stars just starting to pop out from them. So from a scientific point of view, it's fascinating, but fundamentally, it's a very pretty picture.
I think my favourite photo is something you can't see with the naked eye. It's the Hubble Deep Field image, the one where you look at it and you realise that there are faint blue objects in that image that are, they're about 10 billion years old, and you just think, you're looking at it, that light has been travelling for 10 billion years, and it's just remarkable. That's the remarkable thing about astronomy. When you look out, you're not just looking at beautiful things, you're not just looking at large distances, you're looking back in time.
watching. I hope you enjoyed this video presentation. If you did, please subscribe to my YouTube channel, like the video, and share it on your favorite social media sites. There's a lot more to come, so stay tuned, and we'll see you back next time.
Greetings, fellow humans. Well, this is my first ever attempt at making a legitimate YouTube video, so bear with me as I muddle through this. For starters, let's get the intros out of the way. I'm the Biker Scout. And a little background about me, other than the obvious Star Wars reference, I ride a motorcycle full time. But I'm a professional designer and photographer first. I've been using Photoshop since 2.0, is that 1990-ish? So I know my way around a computer and photo editing software. And I just had to make this video in response to the crap that NASA's been feeding us as scientific proofs for the general archives and public domain, when in fact they're employing very amateurish photo retouchers. I'm a stickler for details and an avid pixel peeper, and I'll tell you what, if I was employed by NASA, the fake images would be flawless. There are so many absurd photographic anomalies in their archives, but I'm only going to focus on a couple that have all been released within the last few months here in 2015. So let's get started. Alright, let's go straight to the horse's mouth here and download the image right off of NASA's website. And open it into Photoshop. Okay. Now, one thing that you should know is there are all kinds of different blacks. So, in order to see what's actually black, or slightly black, you invert the image. Now, in doing this, you reveal some very interesting characteristics of our perfectly round sphere globe Earth here, which we're told it's an oblate spheroid and not perfectly round. But Photoshop round tool selection marquee thing here will disagree. Now, as I make a selection here, and let me scoot this back on the screen. Okay, I'm not exact size, but it doesn't matter for this because I'll show you why here in a minute. The marquee tool has a very distinct stair-step shape in the pixel definition. And as you can see here, NASA's image, as you toggle around between the feathered edge, that the stair-step matches perfectly with an exact sphere. That means they used Photoshop to delete the background. But they didn't do a very good job. As you can see here, there's a bunch of little random pixel anomalies floating in space. The most obvious that nobody really saw until you invert the image is up here. This is a strip of blue sky cloud that somebody forgot to erase. Now, this is very obvious when you invert the image back. And look at that. That is blue water, people. And it should not be out in space unless this was a retouched image. This is not an official photograph of Earth from 1 million miles away, as they're saying. There's a lot of things about this image that I don't really like in terms of clarity and definition that just can't be taken from a 4 megapixel camera from 1 million miles away. I mean, the detail's astonishingly ridiculous. I mean, you can clearly make out the Central Valley in California. You know, you can see land details. 4 megapixels, 1 million miles away. I don't know. Alright, moving on. Let's check out Commander Scott Kelly's photograph of the Earth, Moon, Venus transit. Really beautiful image. But let's see what we can find here. He's a Nikon user, as are all the astronauts. That will become of importance here later on. I'll mention that in a minute. First, let's open it and do what we did before. We'll invert the image, and we'll see if there's any strange things afoot. My suspicion was the lens flare. It looked too Hollywoodish to me. It looked too much like a plug-in or a filter. But I was blown away when I saw this really glaringly obvious cover-up of something. Now, to me, it looks like they just took the brush tool and blocked something out by just selecting black. But they didn't use the eyedropper tool to sample the nearest color black. So they're, like I said, blacks aren't all the same once you start looking at it as an inverted image. It looks black. Now they may have blocked something out for artistic reasons, but as soon as you do that, it's a manipulated image. And you can't claim it as authentic. You know, it's now a composite. You know, you've edited it, you've retouched it, and I think they're obligated to mention when they do, and not always in the obfuscated terms of mosaic and composite, as NASA always seems to do. Alright, let's check this image out here. Everybody might remember this one. This is the famous moon transiting the Earth in front of NASA's Discover satellite that's 1 million miles away, parked up in geosynchronous orbit. Okay, let's right-click this bad boy, put it in Photoshop. It's a GIF for animated purposes, but the cool thing about GIFs is you can actually open them up in Photoshop and you can see all the layers that the GIF is made out of. Kind of cool. So let's zoom in here and check it out. Alright, you start activating layers and the moon comes into frame. But what is this? Why is the leading edge of the moon green? Obviously, that shouldn't be like that. So, what's going on here is NASA has South Parked a dim moon image because they said it's the dark side of the moon, so obviously we think the image needs to appear darker, but it's passing right in front of the Earth, in front of the sun, sun, full moon, so that means it should be bright, really bright, bright as the clouds, in fact. There's more green fringing, keep turning on these layers. Obviously they were able to delete the green fringing on the leading edge as it left the frame, but they were pretty lazy here as it exited the frame. More green fringing. Now, it seems to me like they just used some green screen software and plucked, or tried to get a nice clean image, but they couldn't because here's a bunch of pixel noise all over the place. That means nobody actually did anything. They clicked the button and they tried to use the algorithm to remove the green. Didn't do a very good job of that. Now, there's a lot of problems with this, image that people have noted already. The clouds obviously don't move, and if this was taken over a period of time, clouds move pretty fast. But the one thing that I really dislike about this image is the fact that who's got the real moon? Commander Scott Kelly has a picture of the moon from the space station, and he's 237 miles away from his vantage point. Now, or 237,000 miles away from his vantage point. And this Discover satellite image is 1 million miles away, minus 237 miles of distance between the Earth and the moon, yet it looks like a dim, dead rock. If I were to be asked which one is real, well, it looks like Commander Scott Kelly's picture is real, and the NASA one, which they're claiming is real, clearly isn't. It's a cut and paste, and a real poor job at that. Here's one last image showing a famous Earth shot from the International Space Station. It's beautiful. NASA uses Nikon, like I said before, so Commander Kelly has graciously taken a selfie of his own camera, so we see what model it is. We can even see that there's a massive fisheye lens on this thing. But knowing those two things is key ingredient in fixing the photos. So in Photoshop, there's a lens distortion correction filter you can use. You just plug in what kind of camera you have, what kind of lens you have, boom, voila, it flattens the image out and corrects the distortion, whether it's pincushion or barrel distortion or even fisheye. The other thing that's going on in this photo here is, everybody will point out, there's a giant hotspot fairly close to the Earth. If the sun was in fact 92 million miles away, the Earth would be lit in a broad, illuminated, wide swath of light, and not just like a light bulb, as we have here. That's just something interesting I've noticed. But anyway, that's it. That's my YouTube analogy wrap-up video of some things that I've really had a problem with, and I noticed not a lot of people were addressing in their YouTube videos, whether they're flat earthers or NASA conspiracy people or moon debunkers. It's the photography that really gives away their deceit. And I think more ought to be brought up about this. I think they're sloppy, they're lazy, and they're hiding something. What that something is, I don't know. Can we reach any higher than low Earth orbit? Or can we even go to space? Can we go to the moon? Is the Earth flat? Is the sun really close? There's so many ridiculous questions, but when you just look at the photographic evidence, you know something is being hidden. And to me, that raises, a several $trillion question. Does NASA owe the taxpayer a bunch of money back for fraud, every man, woman, and child in America, for lying to us this whole time? Can we take, them seriously as a beacon of science? When everybody in their own camp can't seem to get the facts together. NASA showing us a perfect circle image of Earth. Neil deGrasse Tyson is saying, no, the Earth isn't round, it's an oblique spheroid, more pear-shaped. But that's an official NASA photo. And it's perfectly round. But, it's only perfectly round if you use the Photoshop selection tool. So, yeah, let me know what you guys think, and I think this begs further discussion.
take one sound, please. Apollo 17 astronaut sound.
Because Apollo 17 is the final Apollo flight, because the theme of our mission is that this isn't the end. This is, we just begin to crawl with the Apollo program as mankind. We're just now hoping that we can learn to begin to walk and then press on to the future. And Apollo 17 is sort of an opportunity, I think, to remind not just our country but the world that this is a position that mankind is in today. Retro, Vital, Guidance, Roll, Elliot, CNC, Econ, Surgeon, Procedures, ENCO, FAO, Network.
Release at 2 minutes 17. 10, 9, 8, 7, ignition sequence.
Glued to the window. I don't think I've ever seen anything like it. This is Apollo Control, Apollo 17, moving across the Atlantic now. And on the next revolution, the spacecraft will be on its way to the moon, doing the translunar ejection maneuver.
Guys, I've got the word you wanted to hear. You are go for TLI. You're go for the moon.
Okay, Robin, understand. Go for TLI.
10 seconds.
Velocity with the current speed of about 25,000 feet per second up to around 35,000
cut off on time. Looking great. Well, it's these kind of views that stick with you forever. I'll tell you, if there ever was a fragile, appearing piece of blue in space, it's the Earth right now. Hello, Houston, I've got the limb of the moon. Very good. Got the limb of the moon out the center hatch. Boy, is it big. My goodness. Roger. I'll tell you, when you get out here, it's a big move. Gordy, it's a sight to remember. Roger, Gene. America and Challenger separated and flying a few feet apart at this time. Gordo, this is spectacular. It is absolutely spectacular looking at that command module America down there coming across the surface. We're just tracking them at about a 30-degree dive angle.
Challenger Houston, your go for PDI.
Oh, thank you, Gordy. We are go up here for PDI during the final trim at 4. This is Apollo Control. Comes the moment of truth. As Challenger lights off the big descent engine with power descent, touchdown at Taurus Littoral landing site. 10 seconds. Deal, Ollie. We got Ollie. Proceed on a 99. It took 2, 1, 0. Ignition, Houston. Attitude looks good. Engine override is on. Master arm is off. We got a descent quantity light on. Add ignition.
Challenger, you're go for landing.
Little forward, G. Spinner forward a little. 90 feet. Little forward velocity. 80 feet. Going down at 3. Getting a little gust. There's 460 feet. Going down about 2. Very little gust. Very little gust. 40 feet. Going down at 3. Stand by for touchdown. Stand by. 25 feet. Down at 2. Feels good. 20 feet. Going down at 2. 10 feet. 10 feet. Contact. Stop push. Engine stop. Engine arm. Proceed. Command override off. Mode control ahead. Hold. Pings auto. Okay, Houston, the Challenger has landed.
Roger, Challenger, that's super.
Boy, you bet it is, Gordo. We is here. Man, is we here. How's that look? Pressures look great. Houston, you can tell America that Challenger is at Taurus Littoral. I'm on the footpad. At Houston, as I step off at the surface at Taurus Littoral, we'd like to dedicate the first step of Apollo 17 to all those who made it possible. Jack, I'm out here. Oh my golly. Unbelievable. Unbelievable, but isn't it bright in the sun? Well, I tell you, Dean, I think next generation ought to accept this as a challenge. Let's see them lead footsteps like these someday.
Is that, you got valves manifolds out there?
Well, if we got them where we think we do, then that could be these boulders.
But here's the shadow. See the shadow coming in under? The sun is up here.
Oh, you won't believe it. There goes the fender. Caught it with my hammer and it just popped right off.
Okay, was it the rear fender, you know?
Jack, and I'm just going to put a couple pieces of good old-fashioned American gray tape on it. Except the old-fashioned American gray tape doesn't stick to lunar dust-covered fenders.
Jack Schmidt on his way back to the lunar module.
Pop, pop, I was strolling on the moon one day in a merry, merry month of December. May, that's right. Da-da-da-da-da-da-dee-da-dee. Okay,
Crew,
was using maps to make that fender. We gotta take a picture of that fender if it works. Wait a minute. Want some help, Jack? I'll be there. I don't need any help. Can I change your arm? Okay. Wait a minute. Well, what are the reflections? I've been through one. There is orange file. Well, don't move it till I get here. It's all over. Orange. I can see it from here. It's orange. Crazy. It's been oxidized. It looks just like an oxidized desert soil. That's exactly right.
This is Apollo Control. Gene Cernan and Jack Schmidt aboard Challenger on the lunar surface. Ron Evans aboard the command module in orbit around the moon.
Hey, Houston, this is America.
Hello, America. Time to turn the recorder on.
Recorder's on.
Okay. We're planning on asking at the scheduled time.
Okay.
As Ron Evans doing his orbital science task and orbital photography. Less than a minute away now as Cernan and Schmidt aboard Challenger on the lunar surface are awakening for the third moonwalk.
If I may, I'd like to remind everybody the Valley of History has seen mankind complete its first evolutionary steps into the universe. No more significant contribution has Apollo made to history. And I think everybody ought to feel very proud of that fact.
Now let's do the same thing, but clap. One single clap. 1, 2, 3. 1, 2, 3.
When we return to Houston, we'd like to share a piece of this rock with so many of the countries throughout the world. We hope that this will be a symbol what the feelings of the Apollo program are, and a symbol of mankind as we can live in peace and harmony in the future. Bob, as I take me this last step from the surface, I'd like to just let what I believe history will record that America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon in Taurus Littoral, we leave as we came, and God willing, as we shall return with peace and hope for all mankind. Stand by for 5. 99, proceeded, 3, 2, 1, ignition. Right away, Houston. Vector good. Next start.
Now we've got a good picture of the Challenger coming up from the surface of the moon.
It's coming straight up, all right. Trying to close it at 5 feet per second, 440 feet. Okay. Stand by. Looking good. Stand by. We got capture. Capture. Okay, Houston, we have capture. Houston, America has found some fair winds and following seas, and we're on our way home.
I'd like to read the following statement by the President of the United States of America. As the Challenger leaves the surface of the moon, we are conscious not of what we leave behind, but of what lies before us. The dreams that draw humanity forward seem always to be redeemed if we believe in them strongly enough and pursue them with diligence and courage. To Gene Cernan, Jack Schmidt, and Ron Evans, we say Godspeed. You safely back to this good Earth.
And we're now showing Apollo 17 enters Earth's atmosphere.
Okay, Bob, we're looking good on board at 4 seconds from our RT.
Roger,
RT. There's your right. Cut to your right.
and beginning a blackout approximately 17 seconds after entry interface into the atmosphere, 400,000 feet or approximately 85 miles above the Earth.
Hello, America. Houston. Over.
Should be coming out of blackout, and hopefully we will have confirmation from the crew on drogue deployment and main parachute deployment.
America, this is Houston.
Apollo 17. Hello, recovery. It's a beautiful day. We're out at 610. We got 3 good rains.
real fast from the recovery helicopter. Best wishes from management, flight controllers, other people who have been associated with the Apollo program for the past 10 years.
It's not just the end. We're not putting our rockets in the bar and closing the doors. We're just beginning to understand and accept the challenges that this universe has for us. Apollo 17 has that responsibility. I think it has, we want to express a feeling to the people who made it possible that they've done a great thing for this nation and for the world, and let them know that it's not the end, but it truly is a beginning.
The discovery of water on the moon. According to a NASA press release this week, the argument that the moon is a dry, desolate place no longer holds water. Substantial water reserves have been found beneath the moon's surface, paving the way for a permanent lunar base. Preliminary data from the Lunar Crater Observation and Sensing Satellite, or LCROSS, indicates that the mission successfully uncovered water during the October 9, 2009 impacts into the permanently shadowed region of Cabeus Crater near the moon's south pole. This discovery opens a new chapter in our understanding of the moon. The impact created by the LCROSS Centaur upper stage rocket created a two-part plume of material from the bottom of the crater. The first part was a high-angle plume of vapor and fine dust, and the second, a lower-angle ejecta curtain of heavier material. This material has not seen sunlight in billions of years. After traveling approximately 113 days and nearly 5.6 million miles, or 9 million kilometers, the Centaur and LCROSS separated on a final approach to the moon. Traveling as fast as a speeding bullet, the Centaur impacted the lunar surface with us watching with its onboard instruments. Approximately 4 minutes of data was collected before the LCROSS itself impacted the lunar surface. However, the impact was barely discernible, and for several hours NASA was unable to confirm that a plume had been detected at all, after having initially said that it would be visible through handheld telescopes from Earth. NASA later said that LCROSS did indeed photograph a plume, but that the live video stream was not properly attuned to pick out the details. Vincent Eek from the University of Durham, who helped the American Space Agency pick the location, said that the much smaller plume may have been a result of the large quantities of water. A high proportion of the capsule's energy on impact would have gone into vaporizing the ice, meaning there was less energy left to kick the dust up to high altitudes. Scientists are now hoping to establish the origin of the water. One possibility is that it was deposited by comets over as long as billions of years, meaning it could hold important clues to the history of the solar system. The discovery was announced by project scientists Anthony Colapri at a midday news conference. I'm here to tell you that indeed, yes, we found water. And we didn't just find a little bit, we found a significant amount. About a dozen 2-gallon bucketfuls, he said, holding up several white plastic containers. The exact form of the water is not yet clear, but it is likely to be spread out in small ice crystals. The moon remains drier than any desert on Earth, but the water is said to exist on the moon in very small quantities. 1 ton of the top layer of the lunar surface could hold about 32 ounces of water, researchers said. Finding water on the moon would be a boon to possible future lunar bases, acting as a potential source of both drinking water and fuel. Lunar ice, if bountiful, not only gives future settlers something to drink, but could also be broken apart into oxygen and hydrogen. Both are valuable as rocket fuel, and the oxygen would also give astronauts air to breathe. NASA's current exploration plans call for a return of astronauts to the moon by 2020, for the first visit since 1972. Michael Warko, chief lunar scientist at NASA headquarters in Washington, said the latest discovery could also unlock the mysteries of the solar system. He listed several options as sources for the water, including comet, solar wind, giant molecular clouds, or even the moon itself through some kind of internal activity. If the water that was formed or deposited is billions of years old, these polar cold traps could hold a key to the history and evolution of the solar system, much as an ice core sample taken on Earth reveals ancient data. In addition, water and other compounds represent potential resources that could sustain future lunar exploration. Gregory Delory of the University of California, Berkeley, said the findings of LCROSS and other spacecraft were painting a really surprising new picture of the moon. Rather than a dead and unchanging world, it could be, in fact, a very dynamic and interesting one. When Apollo astronauts returned from the moon 40 years ago, they brought back several samples of lunar rocks. The moon rocks were analyzed for signs of water found to minerals present in the rocks. While trace amounts of water were detected, they were assumed to be contamination from Earth because the containers the rock came back in had leaked. Analysis of the dust thrown up from the LCROSS impact revealed the presence of about 80 liters of water, or enough for a shallow bath. The results suggest that much larger, more accessible reserves are available at the poles. Scientists have long speculated about the source of vast quantities of hydrogen that have been observed at the lunar poles. The findings are shedding new light on the question of water, which could be more widespread and in greater quantity than previously suspected. Since the impact, the LCROSS science team has been working almost non-stop analyzing the huge amount of data the spacecraft collected. The team concentrated on data from the satellite spectrometers, which provide the most definitive information about the presence of water. A spectrometer examines light emitted or absorbed by materials and helps identify their composition. We were only able to match the spectra from LCROSS data when we inserted the spectra for water, said Colaprit. No other reasonable combination of other compounds that we tried matched the observations. The possibility of contamination from the Centaur was also ruled out. There are potentially two types of water on the moon, that brought from outside sources, such as water-bearing comets striking the surface, or that which originates on the moon. A second, endogenic source is thought to possibly come from the interaction of the solar wind with moon rocks and soil. The rocks and regolith that make up the lunar surface are about 45% oxygen. The solar wind, the constant stream of charged particles emitted by the sun, are mostly protons or positively charged hydrogen atoms. If the charged hydrogens, which are traveling at 1/3 the speed of light, hit the lunar surface with enough force, they break apart oxygen bonds in soil materials. Where free oxygen and hydrogen exist, there is a high chance that trace amounts of water will form. The various study researchers also suggest that the daily dehydration and rehydration of trace water across the surface could lead to migration toward the poles, where it can accumulate in the cold traps of permanently shadowed regions. The LCROSS science team, along with colleagues, are poring over the data to understand the entire impact event, from flash to crater, with the final goal being the understanding of the distribution of materials, and in particular, volatiles, within the soil at the impact site. The full understanding of the data may take some time. The data is that rich, said Colaprit. Along with the water in Cabeus, there are hints of other intriguing substances. The permanently shadowed regions of the moon are truly cold traps, collecting and preserving material over billions of years. LCROSS was launched in June of 2009 as a companion mission to the Lunar Reconnaissance Orbiter, or LRO, from NASA's Kennedy Space Center. After separating from LRO, the LCROSS spacecraft held onto the spent Centaur upper stage rocket of the launch vehicle, executed a lunar swing-by, and entered into a series of long looping orbits around the Earth. LRO continues to make passes over the impact site to give the LCROSS team additional insight into the mechanics of the impact and its resulting craters. What other secrets will the moon reveal? Stay tuned. This is Rita Carl, Director of Education for Challenger Center for Space Science Education, signing off.
NASA scientists have discovered not just a little water on the moon, but vast amounts of water. And John Berman is here on what they found and what it means.
In just this one moon crater, the equivalent of 1 billion gallons of water, enough to fill 1,500 Olympic-sized swimming pools. And if there's that much in one crater, there's no telling how much more there is on the moon as a whole. But scientists say much more than they ever imagined.
Liftoff.
This is all the result of a flashy $79 million experiment NASA launched last year, the so-called moon bombing. The idea was to send a rocket crashing into a crater and then analyze the makeup of the dust cloud. The whole world watched, expecting some kind of spectacular explosion. The visuals turned out to be a dud, but the science, a huge splash. It kicked up ice particles containing 50% more water than their highest predictions. Why does this matter? With that much water, astronauts could live off the land. The melted down water could supply a hypothetical lunar base.
If we're going to explore, the moon is in our future, and we will go there.
And liftoff of
the thing is, right now, the U.S. has no plans to visit the moon. President Obama canceled the mission to go there.
I just have to say, pretty bluntly here, we've been there before.
In the near term, it may be China or India that gets to quench their thirst. Both have pledged to reach the moon in the next 15 years. Some American scientists we heard from today say they hope the new discovery will make the White House reconsider its plans to cancel the moon mission. They found much higher levels of hydrogen and other elements on the moon that could be used for stuff like rocket fuel. One scientist called the moon a treasure chest, Diane.
Long way from green cheese. We have to. Thank you, John Berman.
Well, if humans have any future living on the moon, we'll need a supply of water. Today's mission was to investigate if it exists there in significant quantity. The planet's south pole was chosen as the target. Some craters there are permanently in shadow, so they're very cold, upping the odds of there being ice. NASA sent up a huge spacecraft, which separated into two parts. The first, larger section smashed into the lunar surface at over 5,000 miles an hour. It was hoped that would throw up debris 6 miles into space, with the trailing module then flying through the dust cloud, analysing the particles for traces of water before hitting the surface itself. The actual pictures, however, were rather less inspiring. There were no spectacular flashes and no obvious signs of flying debris. The scientists, though, insist it was a success.
I can certainly report there was an impact. We saw the impact, we saw the crater, and we got good measurements, spectroscopic measurements, which is what we needed, of the impact event. So we have the data we need to actually address the questions we set out to address. And that's the fundamental bottom line. That's what I hope you can take away today is, I'm not going to say anything about water or no water, but we got the measurements we need to address the questions.
Analysis is also being done on telescopes on Earth. They're looking out for dust in the atmosphere over the moon's south pole created by the two impacts. A lot is riding on this experiment. In May, President Obama ordered an independent review of NASA's plans for human spaceflight after the retirement of the shuttle next year. If it turns out there is water on the moon, it could give NASA the boost it needs.
Watching the remaining few seconds of the Alcross mission as we approach very rapidly the surface of the Cabeus crater.
Mark, transition to DV mode.
Flight, NIR2, OPR change request, NIR2 to OPR 10, over.
That copy, NIR2 to OPR
Yes, confirm.
10.
November.
Ready? Command flight in November, IR2 to OPR 10. Command sent.
Flight payload confirm receipt of command.
Copy payload. Stand by for shepherding spacecraft impact.
The very last seconds of the shepherding spacecraft trajectory as it approaches the lunar surface. We are seeing very small craters within the crater.
We confirm a thermal signature of the crater. Our mid-IR cameras. Over.
Copy science.
We just received
flight shepherding spacecraft impact. Stations report LOS.
The ground stations at Goldstone just reported a
last track is 11:35:35.054 seconds.
The pitcher, steroid Santa Claus, kicks and deals. It's a long fly ball going back, and the ball shatters the sky, bringing the ocean itself down into the stadium. Oh, Simpson just broke this dream's reality wide open.
Tracks of audience feedback.
After 37 years without use, the thrusters on NASA's Voyager 1 successfully fired up for the first time. It's giving new hope to the agency's most versatile spacecraft. Trinity Chavez reports tonight.
40 years ago, 2 Voyagers began their odyssey into space. After 37 years of inactivity, NASA engineers have managed to fire up the backup thrusters of Voyager 1, humanity's farthest and longest-lived spacecraft.
I think none of us knew when we launched 40 years ago that anything would be working for such a wonderful long journey.
Sent into space on September 5th, 1977, Voyager 1 was launched 16 days after its twin, Voyager 2. The spacecraft was meant to study the outer reaches of the solar system as a part of the Voyager program, and despite its vast distance, it still communicates with NASA to receive routine commands and return data.
We still communicate with the Voyagers. They send us signals every day.
Anyone could check out the most basic data it transmits in real time on the website. We had a look for ourselves and found that it's moving at more than 56,000 kilometers per hour, and it travels some 1,400,000 kilometers through space each day. And even traveling at the speed of light, the signal took approximately 17 hours to travel from NASA to Voyager 1 in interstellar space. After decades of inactivity, NASA engineers managed to fire up the backup thrusters of the spacecraft. According to NASA, these thrusters fire in tiny pulses or puffs, lasting mere milliseconds to subtly rotate the spacecraft so that its antenna points to our planet. The Voyager team is now able to use 4 backup thrusters that haven't been used since 1980.
The transmitters on Voyager spacecraft are slightly over 20 watts, about what your refrigerator light bulb would give off. But when the signal crosses that vast distance to us, the strength of the signal is 1/10 trillionth of a billionth of a watt, which is the equivalent of 1 divided by 10 with 21 zeros after it.
According to NASA, with the thrusters that are still functioning after decades without use, they will be able to extend the life of the Voyager 1 spacecraft by 2 to 3 years. After 40 years, NASA's twin Voyager spacecrafts are still going strong and still sending home information about the galaxy and beyond. Reporting in New York, Trinity Chavez, RT.
What do marine fossils on the top of Mount Everest tell us about the biblical flood? Well, we find fossils of marine creatures in limestone near the summit, which means that this area must have been under the sea in the past. Everyone agrees that the top of Everest was once under the sea. However, many people do not associate these rocks and fossils with Noah's flood because they think there is not enough water to cover the highest mountains. However, they are not considering how the flood changed the Earth's topography. The mountain ranges formed at the end of the flood. With vertical earth movements towards the end of the flood, the mountains rose and the water flowed off the continents into the newly formed ocean basins. Indeed, mountains must have formed quickly and recently, otherwise they would have eroded as quickly as they formed. That's why we have marine fossils at the top of high mountains.
To find out more from Creation Ministries International, visit our website, creation.com.